This problem, we're going to go ahead and finish up part A of the final review. This is page 6, problems 17 through 22. We're going to look at rational functions. The first thing that we want to do is state the domain for each of the functions. So remember that domain the denominator cannot equal 0. So that's what we're going to do, is just work with our denominators. For a, we want to set x squared minus 2x equals 0. We can factor this. We can factor out an x. We are left with x minus 2 equals 0. And now set each factor equal to 0. So we get x equals 0. And if we set x minus 2 equal to 0, we can add 2 to both sides. We get x equals 2. So our domain is x is not equal to 0 or 2. For b, same thing. I'm going to work with the denominator. This is difference of squares, so we can go ahead and factor it out. We get x and x. 16 is 4 and 4. And we have different signs. So if we set each factor equal to 0, I can add 4 to both sides in the first one and get x equals 4. The second one, I can subtract 4 from both sides, and I get x equals negative 4. Now remember that we want our denominator not equal to 0, so x cannot equal 4 or negative 4. For 18, we want to simplify the right side of the function. So for a, to simplify, we're going to go ahead and factor. In the top, we can factor out a 6. We are left with x minus 2. In the bottom, we can factor out an x. We are left with x minus 2. And we can cancel the common factor of x minus 2. So this is equal to 6 over x. For b, in the top we can factor out a 4. We are left with x minus 4. Forgot my f of x. So we factor out a 4, we are left with x minus 4 over, denominator is difference of squares. We get x minus 4, x plus 4. We can cancel our common factors of x minus 4, and we are left with 4 over x plus 4. All right, that's 18. Let's go ahead and look at 19. We have performed the indicated operations. We're going to start with some additions and subtractions. So a, we have y squared minus 6 over y squared plus 9y plus 18 minus y minus 4 over y plus 6. I'm going to start by factoring the bottom on a. This is y plus 6 and y plus 3. 6 times 3 gives us the 18. 6 plus 3 gives me the 9. So my LCD is y plus 6 and y plus 3. So the second fraction, we already have the y plus 6. I want to multiply the top and bottom by y plus 3. Okay, so we're going to go ahead and write this as one single fraction. We get y squared minus 6 minus y squared minus 4y. Sorry, we do outsides next. Plus 3y minus 4y, my insides, and my last is minus 12. All over y plus 6 times y plus 3. As this is a subtraction problem, we want to be very careful. We want to make sure that we remember to distribute our negative. So I'm going to do that now. If we distribute our negative, we get y squared minus 6 minus y squared minus 3y plus 4y plus 12 over y plus 6, y plus 3. If we combine our like terms, my y squareds cancel. I can combine negative 3y plus 4y, that gives me y. And I can combine my minus 6 and my plus 12 to give me plus 6. Final step, we want to go ahead and cancel common factors, so we can cancel the y plus 6, and we're left with 1 over y plus 3. All right, that is example A. Let's move to example B. Example B, we have 2x over x plus 2 times x minus 3 plus x over x plus 2. So what is our LCD? Our LCD is going to be x plus 2 times x minus 3. So for this one, the first fraction we are okay. The second fraction we want to multiply by x minus 3 to the top and the bottom. So if we do this, we get 2x plus, I'm going to go ahead and distribute, x squared minus 3x. Over x plus 2, x minus 3. We can combine our like terms. We get 2x and negative 3x. Combine to give me minus x over x plus 2, x minus 3. Now if you want, you can factor the top, but it's not going to simplify. We won't be able to cancel it with anything. And so at this stage we are done. All right, let's look at example C. Example C, we have a division problem. First thing, remember when we divide, we do not need LCD. What we need to do is copy dot flip. So if we copy dot flip, we get v plus 5 over v squared minus 6v minus 55 dot v squared minus 4v minus 77 over v minus 8. From there, we want to go ahead and factor. So we get v plus 5 stays the same, it does not factor. On the bottom, we get v and v. Things that multiply to 55 and subtract to 6, this is going to be 5 and 11. The negative 55 tells me different signs, and I want my larger number to be negative. So we get minus 11 and plus 5. Okay, on the right side, we can factor the top. We get v and v. 77, what multiplies to 77 and subtracts to 4? We get 7 and 11. Again, we have different signs. I want my larger one to be negative. So we'll get negative 11 and positive 7. Okay, then we go ahead and cancel. What can we cancel? We can cancel the v plus 5s. And we can also cancel v minus 11. So what are we left over with? On top we have v plus 7, and on bottom we have v minus 8. And we're done. All right, last one. This is already a multiplication problem, so we're going to start with factoring. The top on the left, we can factor out a greatest common factor of 2. We are left with n plus 3. The bottom, we get n and n. Things that multiply to 15 and combine to 8 is going to be 5 and 3. Since we are multiplying to a positive 15, this tells me same signs, and they are both positive. So we get plus 5 and plus 3. For the second one, on top, we can factor out a greatest common factor. We get 3. Inside, if we divide each term by 3, we get n plus 5. On bottom, we can factor. N squared is n and n. Things that multiply to 28 and combine to 11 is going to be 7 and 4. And they have same signs. Both are positive. Okay, now what can we cancel? If we cancel common factors, we can cancel the n plus 3s, and we can cancel n plus 5. So what are we left over with? If we multiply the tops, 2 times 3 is 6 over, on bottom we have n plus 7 and n plus 4. All right, that takes care of our multiplying and dividing rational expressions. All right, the next thing that we're going to look at is radicals. And so remember that we're going to be going ahead and factoring this. So some things that we want to know. Assume that each variable is non-negative. We never talked about what to do if we are assuming that the variable can be any real number. So don't worry about what that means. Last thing we want to do is write in radical notation. So for example A, we have the cube root of 8m cubed n to the 7th. So remember that what we want to do is we want to split this up into two groups. The first one will be our cubes. The second one will be leftovers. So starting with the number, 8 is a perfect cube, so we're going to keep it with in our first group. M cubed is a perfect cube, so we're going to keep it in our first set. For n to the 7th, I want to know what is the largest number that is divisible by 3. So 6 is the largest number less than 7 that is divisible by 3. So I'm going to put n to the 6th in my first set. And the leftover, we have one leftover in my second set. So now if we go ahead and break this up, we get the cube root of 8 is 2. M cubed is m. The cube root of n to the 6th, if we divide the exponents, we get 6 divided by 3 is 2. And we still have the cube root of n that we bring down. And we're done. All right, let's look at another one. Let's look at B. B, we have the square root of 24, x to the 5th, y to the 12th, and z. This one, this is a square root, which means that our magic number is going to be 2. Okay, so if we split this up into two categories, into two groups. So what is a square that divides into 24? That is going to be 4. Our leftover is 6. Do a quick check. Are there any squares inside of 6? The answer is no, so we're okay there. Okay, x to the 5th. I want the largest exponent that is divisible by 2 and is less than or equal to 5. So x to the 4th is divisible by 2. I have 1x left over. Y to the 12th. Since it is an even exponent, it is a square. So I'm going to put the entire thing in my first set. And then z, that's just one z. It is not a square and it contains no squares, so we are going to put it in the second set. All right, if we go ahead and simplify now, we get the square root of 4 is 2. Square root of x to the 4th, we divide 4 by 2, we get x squared. And the square root of y to the 12th, divide 12 by 2, we get 6. We leave our 6xy inside the square root, and we are done. All right, last one. We have the cube root of 40a to the 6th, b to the 10th. This is a cube root, so we are looking for perfect cubes. So what is a cube that divides into 40? That is going to be 8 times, my leftover is 5. A to the 6th, 6 is divisible by 3, so I'm going to leave it in with my perfect cubes. For b to the 10th, what is the largest number less than 10 that's divisible by 3? That's going to be a 9. And we have 1 left over that we'll put with the 5. So now if we go ahead and take the cube root, we get the cube root of 8 is 2. If we divide 6 by 3, we get 2. And if we divide 9 by 3, we get 3. We bring down our cube root of 5b, and we're done. All right, let's see what else we're going to do. Last one, 21, we want to state the domain for each function. So our domain we want the inside greater than or equal to 0. So for A, we're going to have x plus 3 greater than or equal to 0. And if we solve this, we get x is greater than or equal to negative 3. It does not say write in interval notation, so you can if you want to. I would just leave it like this. So we're done with example A. So for example B, same thing. I want to set my inside, my x minus 4, greater than or equal to 0. We can add 4 to both sides, and we get x is greater than or equal to 4. And that's our domain. Okay, for our last problem for part A, we have 22. We want to find x such that f of x equals 0. Notice this is not x equals 0, this is f of x equals 0. So we want to replace this part with 0. So if we do that, we get 0 equals 2 square root of x minus 3 minus 6. So in order to solve this, we're going to isolate our radical. I want to add 6 to both sides. And I want to divide by 2. We get 3 equals the square root of x minus 3. To get rid of the square root, I square both sides, and we add 3 to both sides to get x by itself. So we get x equals 12. And we're done. Okay, let's look at B now. Again, I want to replace f of x with 0. We get 0 equals 8 plus 2 square root of x minus 4. To solve, we're going to go ahead and subtract 8 from both sides. We get negative 8 equals 2 square root of x minus 3. We divide both sides by 2, and we get negative 4 equals the square root of x minus 3. Now, square roots cannot equal negative numbers. And so this one, if you want, you can stop here and say no solution. If you do decide to continue this, we would square both sides. We get 16 equals x minus 3. Add 3 to both sides, and we get 19 equals x. But here's the thing you have to check. If we check this, I want to know, if I plug this in, do I get 0? 19 minus 3 is 16. Square root of 16 is 4. Two times 4 is 8. And 8 plus 8 is 16. Is 16 equal to 0? The answer is no. And so 19, if you recall, what do we call this? This is called extraneous. Okay, that takes care of part A of the final review. So take a quick break and then come back and we will start looking at part B.